Today we're going to be working with the distributive property and combining like terms. So first thing that you need to do is flip to our vocabulary section and write in this information. So the distributive property is a method of simplifying expressions of multiplication along with addition or subtraction. Again, this should be a review topic. We're going to look at some examples here shortly. When we use the distributive property, we also can combine like terms when possible. When we're talking about like terms, we're talking about terms with exactly the same variable factors. So those letters. And then coefficients. The coefficient is that numerical factor when a term does have a variable. So the number in front of the variable is what we call the coefficient. So vocabulary to be familiar with, we'll be using in today's lesson, distributive property and like terms. So if you flip to that section of your flip book, just a quick review of distributive property. When we have a number being multiplied to a parenthesis, we are going to distribute. I'm going to quick finish our recording here. So I distribute the A to the B, and I'm multiplying A times B, keep that plus sign, and I have the A times C. Same thing happens here to the right. We just have the A after the parenthesis. It's still being multiplied, so I have to distribute the A times the B plus the A times the C. The same thing works if we're subtracting inside the parenthesis. We're still multiplying when we distribute A times B minus A times C. And again, if the term is on the outside of the parentheses on the right instead of the left, we still distribute A times B minus A times C. So when we look at example 1, they want us to use the distributive property for mental math. So I don't want to multiply 8 times 49 longhand. I want to use this idea of distributive property so that I could work it in my head. So my 8's going to stay in front. In the parenthesis with that 49, I want to split that up into chunks of numbers that I can work with easily. So I know from the previous screen I can either use addition or subtraction. If I were to do addition, I would split my 49 up into 40 plus 9. Because I can multiply powers of 10, I can just multiply the 8 times 4 to get 32, add my 0 on, 8 times 9 is 72, and I get an answer of 392. If I were to do subtraction instead, which I like better for this particular problem, I can do 50 minus 1 instead of the 40 plus 9. I still get that 49. 8 times 5 is 40. Add the 0. Minus 8 times 1 is 8. And I still get that same answer of 392. So I would like you to now work B, C, and D. So let's take a look at those. For B, I would split my 303 to 300 plus 3. So I'm going to get 7 times 3 is 21. Add the 2 zeros. Plus 7 times 3 is 21, which gives me an answer of 2,121. With C, some of you used addition. This one, again, I would rather use subtraction and split using 20 minus 1. If I do 10 plus 9, I would need to be able to multiply 62 times 9 in my head. Not sure that everybody would be able to do that. So 62 times 2 is 124, minus 62 times 1 is 62, which gives me an answer of 62. And that is not correct because I forgot my 0. So let's try that again. 62 times 2 is 124, add my 0, minus 62, which gives me an answer of 1,178. For D, again, you could use addition or subtraction. If you're using addition, you would need to split this up 3 ways, 300 plus 90 plus 8. I again prefer the subtraction, 400 minus 2. 6 times 4 is 24, add the 2 zeros, minus 6 times 2 is 12, which gives me an answer of 2,388. So you will see some of those problems occasionally, okay? I know you can come up with the answer another way, but the directions specify for you to use the distributive property and mental math. In example 2, we're working problems that we would typically see in algebra using distributive property. So my 4 in front needs to distribute. 4 times 2x is 8x. And then I'm distributing to a negative 8. 4 times negative 8 gives me negative 32. In F, the term that needs to be distributed is at the end, and it's also negative. So I need to be very careful because I'm distributing a negative 6. A negative times a positive gives me a negative 18b squared. I'm distributing to a negative 4b because subtraction means that I am adding the opposite. So negative times a negative gives me a positive 24b. And then a negative times a positive gives me a negative 72. So I'll give you a little bit of time to work G and H. If we come back to these problems, okay, distributing here, you should have come up with 63C plus 27. With H, we were again distributing a negative similar to the problem above. So if you did H correct, you should have come up with negative 2x cubed plus 8x squared minus 24. So again, being very careful distributing that negative. You turn to the next page in your flip book. We're going to be looking at combining like terms. So we need to know what it means for a term to be like. So we're going to identify parts of this term. Thinking about our vocabulary, we said the number that we see in front of the variable is called a coefficient. The letter is the variable. And we know from a previous section that this raised number 2 is called the exponent. So down below it says when combining like terms, we are going to combine the coefficients of like terms. So we're combining the numbers in front using addition or subtraction of the like terms. In order to be like terms, the corresponding variables must have the same exponent. So to be like terms, the variable and exponent have to be exactly the same. So if I look in this box, they want me to circle the like terms. So in example I, the 2x squared and the 3x squared are like terms because they have the variable x and the exponent of 2. In the example below, we don't have anything with a variable and an exponent the same, but we do have these two, what we called constants in a previous lesson, which are like terms because they're both constants. We can add together a -5 and a +13. So if we look at these examples, I have like terms in the 7 and 11 because they both have the d squared. So I add the numbers 18, I keep the d squared, and then I'm just going to bring down the +3d. In L, I have like terms in the 2 and the -6t. So when I combine them, 2 minus 6 is -4, keep the t, then bring down the 5, so +5. And then in M, I have the 10a and the minus or -4a, which gives me 6a. And then I also have those two constant terms to combine. -4 plus 7 is a +3. So +3 for combining like terms. And then in this example 4, we're going to be doing a combination of distribution and combining like terms. So when we think about order of operations that we worked with previously, order of operations has us multiplying first, which means we need to use our distributive property first. So I'm going to distribute into the parenthesis only. 9 times 5 is 45, plus 9 times x. Drop down my -6x. Then I have like terms that I can combine. So I'm going to drop down my 45, then I'm going to combine my 9 minus 6, which is +3x. Same kind of thing with the next problem. Distribute into my parentheses. 4 times r is 4r, plus 4 times 8 is 32. Drop down my 7. So then I'm going to combine my constants. So I'm going to just drop down my 4r. 32 minus 7 is a +25. Example P, I'm distributing. -3 times m is -3m. -3 times -4 gives me a +12. Bring down my +2m and my +10. Now I'm going to combine like terms. I have a negative 3m plus 2m, which gives me a negative 1m. But that coefficient of 1 is invisible, because if I use my multiplication property, I know 1 times anything is just that thing. So my 1 is always invisible as a coefficient. I also need to combine my constants, a positive 12 and a positive 10, which gives me a plus 22. So I will give you a couple minutes to work through these other problems. So taking a look at these, for Q, if you worked this one correctly, you should come up with an answer of negative 80 plus 24x. For R, you should come up with an answer of 11 plus 3p. Okay. Some of you struggled with this one because you wanted to add the 5 and the 3 together and get 8 and then distribute. That is not how order of operations work. We have to distribute first. So the 3 gets distributed. So I have 3p plus 6. Bring that 5 straight down. Then I combine my 5 and 6 to get the 11 plus 3p. So the same kind of thing applies for S. You should get a final answer of 14k minus 4. And again, we had to do this distribution before we combine like terms. So that is our lesson on distributive property and combining like terms.